So this is tutorial. So I hope this will ease your understanding about the Reynolds transfer theorem. So water flows in and out of a device as shown below. Calculate the rate of change of the mass of water in the device. So we have a one input here, and then we have two output here. So and then what you need to understand is first we need to check the inlet flow rate or inlet mass flow rate, because at any condition the outlet here must be equal, the total outlet here must be equal to the total inlet of the supply. So this is the idea of conservation of mass. Okay, we go for this one. So and then determine the control volume and the control surface. So in this situation, we will have the control volume like this one. So we just assume that this is the inlet. So and then it is the other is the output, the outlet. So the question is determine the system. In this case, the system is flow rate. So because the N here is equal to meter, so dm dt will give you the value of P in certain time. So and then what we could do is we could simplify the equation into this one. So we have d over dt, integration of control volume, rho volume, plus integration of control surface, rho v and dA. So and then because we know that rho dv here is equal to mass, so we substitute it here. So we could write it is equal to dm over dt. So now we have one term explaining about the mass flow rate. And then for dn dt, so we put it as equal to 0. Why? Because in the continuity equation, we believe that whether you are at any condition, the conservation of mass must balance. So input must equal to output. So means that input minus output will give us total 0. So this is the conservation of mass. So for dn dt here, so if we are doing analysis about the mass flow rate, so it is okay for you to assume it is equal to 0. Why? Because it is the idea of conservation of mass. So and then for the first term on the right here, so you will get the dm dt. So the dm dt here means the increment of mass according to time for certain area for our control volume. So and then we have integration of rho v and dA, means a changes of something on the surface. Okay, so if we see back our free body diagram of our control volume, so this is the our control volume. So we have one input and two output here. So it means that water may be flow into this system. So and then there are water at outlet, so outlet 1 and outlet 2, but maybe it has some increment of mass inside this system. So the increment of this system is the increment of mass per time. So that this dm dt is actually telling us what is the mass flow rate inside the system. So we could write the 0 is equal to dm dt, and then we add, so dm dt is here, so and then we add the value of integration of surface control surface, which is equal to rho vn and dA. So in this situation, to solve the second term of Reynolds transfer theorem, you need to identify where is your control surface, so where is your inlet and outlet surface. So in this situation, we found that this is the inlet surface, so and then this is the outlet surface. So what you need to do, you need to calculate all those inlet and outlet, so and put in your general Reynolds transfer theorem equation. So the equation is here. So we have the integration Cs of rho Vn and dA. So and then we could neglect the idea of integration, because in this situation the speed, the cross-sectional area is fixed. So means it is okay for us not to integrate that equation, because we could calculate the total mass flow rate that occur, that flow from that surface. So we just substitute the value. So we have rho Vn. So the basic idea is rho Vn and dA. So we substitute the rho here, and then we substitute the value of V in vector n. So what is the V on vector n? You need to see what is the direction of velocity, real velocity that flow into your system, and what is the direction of the n vector. If the direction is different, opposite to each other, so means that you need to put a negative sign on the velocity. However, if the direction of n and the direction of velocity is the same, so you could take a positive sign in your calculation. So please bear in mind, if the fluid flow is in opposite direction with your n vector, so you need to give a negative sign in your magnitude. So for inlet here, so we have rho. So because the V1 here is opposite to the n direction here, so we give negative V1, and the cross-sectional area is A1. So and then for cross-sectional area number 2 here, so we have rho, we have positive V2, and we have A2. And the third one is rho V3 and A3. So and then we could substitute all the values. Okay, so we let the dm dt at this side, and then we bring all these three parameters to the left hand side, so we could write as this one. So and then we just substitute with the value that we know from the question. So the rho a1 and v1, so rho is 1000, a1 means the area of that parameter, and the v1 is the velocity. So because the velocity is okay, so after we move to the right hand side, so the velocity here is positive, so we could write as this one. And then for outlet number 2 here, so we are calculating rho A and V. So as long as we know that rho is kilogram per second, A is meter square, and V is meter per second. So according to this one, we could found that the rho is kilogram per meter cube. I'm sorry, not S. The A is meter cube, meter square, and the V is meter per second. So this meter cube can be cancelled with this meter cube. So the equation now is still kilogram per second. So according to the question, we have the mass flow rate for the second outlet, which is 4 kilogram per second. So means that it is okay for us just to substitute the number 4, the value of 4. So and then another way to calculate the mass flow rate is by using the idea of rho AV. So and then the A and V here will give us the value of Q, which is the volume flow rate. So means that to calculate the control surface effect for on the third outlet, so we could use equation of rho A3 V3, or it is equal to rho and Q3, because Q here means the A time V, which is the equation for continuity equation. So, and then we substitute all of these. So we found that dm dt is 38.272 kilograms. So what is the meaning of 38.272 kilogram? So it is referred to this question. So means that the flow rate, we have flow rate from left to right here, and then we have output flow rate on right and at the bottom here. So maybe the total mass flow rate here is not equal to the total mass flow rate at outlet. So because the conservation of mass must be fulfilled, so maybe the M here is actually the increment of mass inside this device. So mean the mass inside the device is getting increase and increase. So at the same time, it could flow out the liquid from that system. So this is the meaning of dmdt that we've put it here.